Everybody good? So here we go. First part says sketch them. All right, do you remember what the exponential looks like?
Yeah.
Somebody do it for me in the air.
It's like this.
It is like that. Very good, Austin. That's what it looks like. So we are going to, on our paper, sketch the exponential function, and we're going to sketch it like this. And we're going to label that point 0, 1. That's your exponential. All right, which function is the next one?
The absolute value.
Absolute value. And what does absolute value look like?
It's a V.
It's a V. Perfect. I could have given this quiz today.
No, thank you.
What's the next one?
Square root.
Square root. What does it look like? Make it for me in the air. What's it look
Like
like?
this.
Square
It
root
starts at
function.
the origin.
It starts at the origin, and now this arcs. I don't want to see like a vector coming out, a straight thing. It's a nice little arc coming out. Everybody good with that? All right, now the next block says write the name of the function. Okay, so who can tell me the name of 2a? Yes, ma'am.
Is it logistic?
It is the logistic function. So 2a is the logistic function. How about 2b? Who can give me the name of that one? That's the greatest integer function. And 2c, who can tell me that one?
Squaring function.
Squaring, or if you prefer, you can say quadratic. It doesn't matter. Whichever one of those words you can remember the best. That's the squaring function. All right, so here's 2, part 2, A, B, and C. Everyone good? All right, now write the equation. All right, so what about 3a? Y equals x. That's called your identity. Y equals x. Uh-oh, what about b? That's your natural logarithm, and the equation is y equals ln x. And c is the one, be careful, it is cosine. Very good. Equation is cos x, cosine x. Everybody okay with that? So here are 9 of them. Part 1, part 2, part 3. There are 3 more left, right? So notice what the last question says. Draw, name, or write equation. So I don't care how you do it, whatever you can do. The 3 that we haven't done. So can you name the 3 that we haven't done?
The reciprocal function.
Okay, so the name is the reciprocal function. Anybody know the equation for that? You don't have to write all 3, but in case you're thinking equations, what would it be? Y equals 1 over x. And anybody air draw the picture for me here?
It's this.
It's the hyperbola one, right? The one that looks like this. Good. So for this question, number 4, you had to list either this, this, or this. Not all 3. Just somehow you had to remember, okay, the reciprocal function's not in there. All right, what else is missing? Austin? The sine function. So when you do your sine function, you'll either write the equation, y equals sine x, or you'll say sine function is missing, that's the name of it, or you'll draw a picture of it. And you remember how to draw the sine function? Through the origin, a hill and a valley, right through the origin. That's exactly right. There's your sine function. So again, for this question, I don't need all 3. I need 1 of those. Whatever you could remember the best. Oh, we're missing 1 more. The cubing function. Have we not done that one? Nope, we haven't. So you can write cubing function. You can write the equation y equals x cubed, or you could draw the picture, and what does the cubing function look like? It's the squiggly through the origin. Looks like that. Okay? Now let's turn it over. would you do the 3 quick sketches at the top on your own? We've turned our paper over now. We're looking at another quiz. It's exactly the same type of thing, and it says sketch these 3 pictures. Can you do that? Next time we have class and we have a quiz, we won't be using our note cards for the quiz. Okay, I don't care if you use them today, but we won't use them on whatever, Thursday, I don't know, whatever I see you again. Okay, you got them drawn? What did you draw for A? What shape did you draw for A? A parabola, a U. No straight lines in that guy. Let's not get it confused with the V. It's a U. Everybody good? For B, I just did this. For B, did you draw this? Notice that point right there at the origin. You drew that? That's what you should have drawn for B. That is your sine function. What did you draw for C? V, absolute value V, right here. This is what you drew for C. Everybody in agreement? No questions about part 1. All right, write the name. What's the name of 2A? Greatest integer. Greatest integer. You need both words. Greatest integer. How about B? Cubing. That's your cubing function. And what about C? Logistic. We write the word logistic right here. Logistic. Do not write LOG. Why do I not want you to write LOG? Because we have a logarithmic function. So we're going to write the word logistic if we want to get full credit. Number 3, what are the equations? What's that first one? A, what is that? Y equals e to the x. So on this quiz, 3A is y equals e to the x. That is your exponential. That's your equation. How about B? Y equals the square root of x. That's your square root function. And what about C? Y equals 1 over x. That's your reciprocal function. This is C, right here, 3C. All right, on this quiz now, looking at the ones we've done, which are the leftovers? Which haven't we talked about on this quiz? Didn't do cosine. What else did we not do? Didn't do the logarithmic function. That's exactly right. And we didn't do the easiest one of all, the identity. Those are the 3 that we were missing. Now, on that last one, again, I said draw a name or write the equations. I named, but you could draw them or write their equation. I wrote their equation. You could name them, so this would be cosine. This would be natural logarithm. And that's the identity. Or linear. Some of you say linear, I'm good with that. Or you could draw the pictures. So is everybody completely clear on what the quiz is going to look like when we get back together in a couple days? Okay, it'll look just like this, only one side on these 12 questions. Okay, get out your note sheets and tell me where I quit blabbing the last time we were together.
Pick up on
I said pick up on page 9 at the top E. I guess that's the only one. All right, so here we go. We had started problem 9E, but we were not done with it. So let's recap what we have already done. Alright, hang on to your hats, people. This is big time math. Alright, this is the big time now. We need to get a prayer thinking caps on and pay attention. You've been waiting all day to come to math class. Let's make it work. How did I start? My job in this problem is to do what? What were my directions? Find the vertical asymptotes. Okay. Will somebody tell me where vertical asymptotes come from? Oh my. Oh my. This is bad news. Where do vertical asymptotes come from? The denominator. The denominator can never be 0. So what I'm going to do is I'm going to start by factoring this problem. And I think I already did this, but I'm doing it again. And what made this problem special? Why did I say we're not done with it? Because we can cancel. So instead of having 2 problems in the denominator, 2 issues, I only have 1 now. So I have 1 vertical asymptote. My job in this problem was to find the vertical asymptote and graph them. Okay? So I'm going to do that. My vertical asymptote is where x equals -5. So you simply draw that on your paper. You don't need to draw anything else. But now I'm going to add to that. Knowing what's coming up, I'm just going to branch off and we're going to talk about what it means when something cancels. When something cancels out of your problem, you have what's called a hole, which simply means whatever this picture looks like, there's going to be an opening in it. The curve is going to skip through. There's going to be an opening, a hole in the picture. The only time holes happen is when you cancel something out. So remember that, because I will say to you, where are the holes? And sometimes there aren't any, because if nothing cancels, you're not going to have a hole. Now, where will this hole be? Keep in mind, the hole is a point. It's an open point, but it has an x-coordinate and a y-coordinate. The x-coordinate for this problem is at 1. I want you to look at what canceled out. If this hadn't canceled out, I would have an asymptote at 1. Would you agree with that, if that hadn't canceled out? As soon as it cancels, instead of having an asymptote there, you're going to have a hole at the same place. So I have a hole where x is 1. But now I need a y-coordinate. Where do you think I'm going to get the y-coordinate? How do I always get y's? By plugging in x's, right? So I'm going to plug 1 into here, and what will I have on the top? 2, and what will I have on the bottom? 6. So I get 2 6, which I will reduce to 1/3. So on my picture, there is an open circle, a hole at the point 1, 1/3. Now, every time we hit a problem like that, we're going to find the hole, okay? Even though the directions don't say, because eventually we're going to need to know how to do that. But we're done with this problem now. You might still have questions. That's all right. They're going to get answered in a minute. Let's look at F. How are we going to start F? We're going to start by factoring it. Okay. Can somebody factor the numerator for me?
X plus 5.
X plus 5, X plus 4. Can somebody factor the denominator for me? X plus 4, X minus 4. What happens? We got another hole. We cancel these out. we have x plus 5 over x minus 4. But before I get too excited about my whole, let's remember we still have a vertical asymptote, right? Where's my vertical asymptote? X equals positive 4. So that's what you have to graph. Everybody see where the 4 came from? Now, where is my whole going to be? I cancel, so I'm going to have 1. Where's it going to be? Where x is negative 4. The opposite. So it's going to be at negative 4. That's what canceled out. If I hadn't canceled, I'd have another asymptote at negative 4. Now, how do I find the y coordinate? I plug in negative 4. So put negative 4 on the top. What do you get when you put negative 4 on the top? 1. What do you get when you put, be careful, when you put negative 4 on the bottom? Negative 8. So you have a whole at negative 4, negative 1/8. I don't know what the rest of that picture looks like. We'll build on it as we go. But right now you've taken care of the vertical asymptote and the whole. Oh my gosh, look at G. What a monster problem. Let's see what we can do with it. Any suggestions? Factor. That's a great suggestion. How does this thing factor? How does the top factor? Watch it now. I know you're thinking 2 and 3, but it's not 2 and 3. X minus 6, x plus 1. Remember, 1 has to be positive and 1 has to be negative. The bottom. What do I do with that? Group it. That was on our test, right? We have to group this side. So what can I take out of the first 2? X squared. And I would be left with x minus 4. And what can I take out of the last 2? Just a negative 1. That's it. And watch it now. If I take out the negative, what am I going to be left with? A positive x and a negative 4. Althea, you doing okay today? Look a little tired, been a long day? Yeah, hard to get back in the swing. So we got x minus 4 as our common factor. And then I have x squared minus 1. Am I done factoring? No, because that factors, right? This guy right here. How does he factor? X plus 1, x minus 1. Wow, I didn't leave enough space, did I? This guy's huge. All right, so I'm going to put asymptotes in there. But before I do that, I better cancel. So I finally, after all that work, I have x minus 6 over x minus 4, x minus 1. Now these did not cancel, which means they're going to be asymptotes. So where are these asymptotes going to be? At positive 4 and positive 1. So your job is to draw an asymptote where x equals 1 and draw an asymptote where x equals 4. Do I draw an asymptote where x is negative 1? No. What's going to happen where x is negative 1? We're going to have a hole. That canceled out. So where is that hole going to be? Well, it's where x is -1, because that's what canceled. And how do I find the y? I plug it in right here. So put in -1, what do you have on the top? -7. Okay, now if I put in -1, I'll get -5 times -2. I'm putting in -1 here, which would be -7 over 10. So on my picture at -1, -7/10, I have a hole, an open circle. Okay, we're getting ready to add another layer on. The next section talks about horizontal asymptotes. We haven't done that yet. So does anybody have a question about vertical asymptotes? They come from the denominator, but before we can graph them, we have to make sure everything's canceled out, because only the uncanceled stuff makes asymptotes. Okay? All right, let's look at the next problem then, talk about horizontal and vertical. Is anything going to cancel in problem 4A? Now, I didn't say, can I factor? I said, even if I did factor, would anything cancel? No. Nothing's going to cancel. And what does that mean about my picture? There simply won't be any holes in it. Does it have a vertical asymptote though? Where is the vertical asymptote? At -3. So I'm going to graph x equals -3. Now this horizontal asymptote thing is based on a concept called the limit. Every time you find a horizontal asymptote in an expression like this, you can find it by simply comparing the highest power that you have in the problem. So we have an x to the first. That's the highest power that we have. We don't have any squares or cubes. If I put 2x over 1x, that would reduce to 2. So my horizontal asymptote is at y equals 2. Now, I'm going to explain that one time. Try to get it. If you don't, it's okay. Just know that's how you do the problem. Here's the logic behind it. If we let x be a humongous number, I mean humongous, like a billion, the numerator, the top of the fraction, if x were a billion, the numerator would be about 2 billion. It wouldn't be exactly 2 billion, but it would be about 2 billion. Would you agree with that? And the denominator would be about 1 billion, if I let x be a billion. So I have about 2 billion over about 1 billion, which is about 2. Now, will it ever actually equal 2? No. But will it get very close to 2? I mean, think about it. If I walked in and said, I'm going to give you $2 billion, but I'm going to keep 4 for myself. Who cares, right? Or I'm going to give you $1 billion and an extra $3. Do these numbers even count? Now we're talking about billions. So 2x over x is 2. That's my horizontal asymptote. No holes. I'm done. Next problem. B. What do you think we need to do first with B? We need to factor it. because this one factors and something might cancel. How does that factor? Top. X plus 2, x minus 2 bottom. X plus 3, x minus 3. Shooty tooty, nothing canceled. What does that mean? No holes. But there's two things down here, which means two vertical asymptotes. So I'm going to have a vertical asymptote at x equals positive 3 and a vertical asymptote at x equals negative 3. Robbie, you got your asymptotes down?
Yeah.
Okay. Now I need my horizontal asymptote. So come back over here. How did I get this one? I put 2x over x. So now I'm going to look at this problem, and I'm going to put x squared over x squared. Where's that horizontal asymptote going to be? Oh no, x squared over x squared. That would be y equals 1. No holes. Two vertical asymptotes, because there's two things in the denominator, and then a horizontal asymptote, y equals 1. C. Tell me where I have asymptotes in problem C. What? I have a vertical at x equals 4. I'm looking at problem C. Would everybody agree I have a vertical at x equals 4? Okay, where's the horizontal? Y equals 1. And why is it at y equals 1? X over x. Couldn't say it better myself. Perfect. X over x. How's come there's no holes? I'm not talking about holes. Why not? Because nothing canceled. You're only going to have holes if something cancels. All right, let's look at D. This is a little harder. Where's that vertical asymptote going to be? Negative 6/8 or negative 3/4. Now, those of you that are struggling with this a little bit, remember, you told me the asymptotes were at negative 3 and 3 back in this problem. And that was because that's what gave you 0. You're not allowed to have 0, so you said, okay, I'm going to have an asymptote there. So do the same thing. 8x plus 6, where is that 0? That's where the asymptote will be. So we subtract 6 and divide by 8. See how he got 6/8? Did you say 6/8 or 8/6?
6/8.
6/8. So negative 6/8, which is negative 3/4. So you're going to have a vertical asymptote, there's 1, at x equals negative 3/4. Where's your horizontal asymptote in problem D? Y equals 3/8. Horizontal is y equals 3/8. Colleen, why is it 3/8? You have 3x over 8x. That's 3/8. That's how you get your horizontal asymptote. Now, of course I got tricky. Look at E. It's tricky. The first part isn't tricky. Can you factor your bottom? Okay, what would it look like if I factored the bottom? X plus 2, x minus 2. So where do I have vertical asymptotes? At x equals negative 2 and at x equals 2. Is that okay with everybody? Now, what's different about this problem? What's tricky about it? On the bottom, I didn't write the problem down. On the bottom, there's an x squared, but there isn't one on the top. If you look back at problem B, it had squares, but it had them on the top and the bottom. This only has a squared on the bottom. So how am I going to figure out the horizontal asymptote? Well, the problem is I don't have any x squareds on the top, right? So let's think of that as no x squareds on the top. Would you agree with that? There aren't any up there. There's 0 x squareds up there. So what happens when I put 0 x squareds over 1 x squared? What does that equal? That equals 0. Your horizontal asymptote is y equals 0. Now, if that's too much for your brain to handle, remember this. Anytime the power in the bottom is bigger, the asymptote's going to be at 0. Anytime, I don't care what the powers are, if the biggest one is in the bottom, then the asymptote is going to be at 0. Okay? Oh, look at F. Where's the horizontal asymptote in F? Horizontal now. Where's the horizontal asymptote?
0.
At y equals 0. Y in F is the horizontal asymptote also at y equals 0. Because the power on the bottom is bigger. There's no x squareds on the top. How do I find my vertical asymptotes? Factor the bottom. And when I factor the bottom, oh, how does that factor? X plus 4 minus 1. So where will my vertical asymptotes be? At negative 4, x equals negative 4, and x equals 1. Jazzy, why is my horizontal asymptote at 0? It's easy, you got it. Anytime the power on the bottom is bigger, your horizontal asymptote is going to be at 0. Okay? Now look at G. Because I'm mean and nasty, what did I do in G? Ah, the rules change when the bigger power is on the top. Think about it for a second. When the bigger power is on the top, that means there's no x squareds on the bottom, right? So I have 1x squared over no x squareds. 1 over 0. Makes my eye twitch. 1 over 0. That should be freaking you out. Can you do 1 over 0? No. No horizontal asymptote. If the power on top is bigger, you can't have 1 because you got a 0 in the bottom. So anytime the power on the top is bigger, there is no horizontal asymptote. There's what we call a slant asymptote. That's for another day. There's no horizontal asymptote. However, does G, problem G, have any vertical asymptotes? Where would the vertical be? X equals 2. So you have a vertical asymptote at x equals 2, but nothing else. No holes, no horizontal asymptote. I must have been in a bad mood when I wrote this, because that is a big problem. That's mean. So I'll just tell you, the top doesn't factor. Does the bottom factor?
Yeah.
How does the bottom factor?
X minus 2.
How?
X minus 2.
X minus 2. Now there's two things down there, but there's only going to be one vertical asymptote because they're the same, right? So that vertical asymptote's going to be where x equals 2. What about a horizontal asymptote? Look at your problem. What about a horizontal asymptote?
No.
None. Why none? Big power is on top. When the big power is on top, the function just keeps growing, and it's not stopped anywhere. It just keeps growing and growing. Any holes in that problem? No, because the only way to get holes is to do what? Cancel. If you're not canceling, you're not coming up with holes. All right, now I need you to open your books. We're going to get these done real quick if we can. To page 113. Now, you can use your flashcards for now. I'm not doing a BFF sheet. I decided to save you some work. We do flashcards together, so don't worry about the sheet. You got your flashcards. That's all you need. And we're going to page 113. And we're looking at number 19. Now, I can't remember with you guys, have I talked about even and odd? Okay. All right, let's do that, and then we'll have to wait and do the rest of those later, because this will take care of our discussion. I'm thinking of 3 functions that I want you to look at. Which one's that? Absolute value. Which one's this? Quadratic, or squaring. And which one's this? Cosine. Those 3 functions have something in common. Can you look at those 3 and tell me what they have in common? Something special. They're all what? You got it. Oh, okay, well, yeah. This one actually goes up and down. I thought you were looking at both sides. Tell me about both sides of this picture.
They're all equal on both sides.
They're equal on both sides. So if I could somehow fold my blackboard on this line, would those pieces come back on top of each other?
Yeah.
How about for this picture?
No.
How about for this one?
Yeah.
Yes. They have what's called symmetry across the y-axis. The y-axis, this vertical line, they are exactly the same on both sides of that vertical line. Would you agree with me? So these functions have symmetry across the y-axis, and that means they are even. The word even to the mathematician means many things, but in terms of functions, even functions have symmetry about the y-axis. That means if I'm the y-axis, and you make a fold, I have exactly the same picture on this side as this side. Okay? Now, not everything is that way. I mean, stop and think about it for a minute. Think of the cubing function. If you folded your paper on the y-axis, if you folded it here, wouldn't you get this picture? That's a different picture. I didn't get the same thing I had. I get a whole different picture. That is not even. Think about your sine function. Is that even? No, don't be confused. If you folded this, you would get this. That's a different picture. These two, though, have something else in common. They have what's called symmetry about the origin. Now, what that means is, if you're a baseball player and you pick up this point right here and you throw it across the origin, you're going to throw it, here's the origin, you're going to throw it across the origin, it would land on another point on the curve. So if I threw this one, it would land here. If this is the point 1, 2, this is the point -1, -2. They're exactly the same point, just thrown across. Symmetry about the origin means you are odd. So when somebody says, is this an odd function, you determine if it has symmetry about the origin. So think about it like this. Quadrant 1 goes to quadrant 3. And 2 goes to 4. Sit down, we're praying. The Lord is with thee.